Okay, in this video I'm going to do a couple more examples of using the product rule to find derivatives. So in this case we've got y equals x minus 3 times x squared plus 7x minus 1. We need to find dy dx, which is the derivative of y. So now in this example I'm going to multiply the two products first, and then we'll differentiate it. So if we multiply it together, we distribute x minus 3 inside the other bracket. So x times x squared is x to the power 3. X plus, times 7x is plus 7x squared. And then x times minus 1 is minus x. And then we multiply the minus 3 now. So minus 3 times x squared is minus 3x squared, and then it would be minus 21x, and then we're left with the last one is plus 3. Now what we do is just add up the simplify it with the alike terms. So we've got x to the squared and x to the power 1, and we leave the rest as it is. So we're left out with x to the power 3. 7x squared minus 3x squared is 4x squared. And then minus x minus 21x is minus 22x. And then plus 3 would come later together. So, and that's equals to y. So what we do now is, after we multiplied it, we simplified it, what we do is just we find the derivative of that. So let's differentiate it then. So we'll have to dy dx equals to x cubed, or x to the power 3 is, we take 3 down, put it next to the x, bring it up next to the x, and then subtract 1 from the power, as you know. And the same thing for here, with 3, bring it down. 3 times 4 is 12. And subtract 1 from the power, so 12x squared. Again, x here to the power 1, so what we do is just we take the coefficient of it, because it's going to be x to the power 0, and everything to the power 0 is 1, so we left out with minus 22, and as you know, the derivative of any number is 0. So that's the final answer. That's the derivative of y, of the y-axis of the equation here. So yeah, that was one of the examples. Let's try another example, but this time we're gonna try to solve a fraction. So let's try to find, let's call this y again. So let's try to find dy over dx here. So what we do here actually is, what I like to do is break down the fraction into smaller fractions, and then like find the derivative of each fraction individually, because that would be a lot easier. So what we can do here is take the numerator, divide each piece in the numerator by the denominator. So that's going to be 6z. By the way, this is z. 6z minus z plus 4 over 2z. So we take 6z over 2z minus the second part, which is z, over the numerator, the denominator, and then the last bit over the denominator. So we're left out with small pieces with 3 fractions, and we take the derivative of each fraction. That will make our lives a lot easier. So, but before that, what we do is we can simplify here. So, like for the first one, I'm sorry about that, it should be z squared here. I apologize for this. So what we do here is we simplify each fraction first, and then we take the derivative. So for the first one, we can simplify 6 with 2, so that would be 3, and we get rid of 2. For z, the z go with the square, so we're left out with 3z here. left out 3z minus. What we do here is z goes with z, so we're left out with 1 over 2, and derivative of any number, because this is a half, it's a number, even though it's a fraction, but it's still a number, a constant only, because the z cancel each other out, so we're left out with 1 over 2, so that would be 0. Any derivative of any number would be 0. And here we've got 4 over 2z. The 2 would go down with the 4, so we're left out with 2 over z. And to differentiate that, what we do is just change the form of the fraction, so we can literally write it down as this. So 2 times z to the power minus 1, because it's in the fraction. If it's in denominator, we put it up. We just change the sign of the power, and now we just take the derivative now. So minus 1 times 2 is minus 2, and we take 1 from the power of the variable, so that's going to be minus 2. So minus 2z to the power minus 2. If you want to put it down in the partial form, or the exponential form, as I like to call it, it's going to be minus z over z to the power 2. So yeah, we just put it down right here. So that's going to be minus, not plus. Sorry about that. That's going to be minus 2 over z to the power 2. So that's how to solve derivatives using partial fractions. Again, like for the first one, what I like to do here is we take we distribute the parentheses or the products first, and then we take differentiation of them. Same thing for here. We break down the fraction first to make it a lot easier, and we differentiate each fraction by itself on its own, and then add them together later. So that's going to be the derivative of that. That's the final answer. So 3z minus 2 over z squared. So yeah, that was it.